Hi everyone, today is Thursday, September the 17th, 2020. It's nice to have a virtual site visit here from the East River. We're actually up in a place many people will recognize straight away, some won't. You're actually looking at the sort of type locality for its name. You're looking at the Redwell. We're of course here in beautiful Redwell Basin today. Wanted to take the opportunity to come up and sort of see what access was looking like for our USGS collaborators. Obviously tied to COVID, their travel restrictions have been pretty challenging as well. But I wanted to take the opportunity to come up and make sure that last week's snowstorm was going to allow travel for sampling for their two well locations. And suffice it to say, it's actually quite beautiful up here today. The entire length of the road was very, very easy to travel and access for now. The weather for the next couple of weeks, or at least the next week for sure, looks lovely. Sadly, it's some of that haze has really started to come in to Colorado over the past few days, emanating from the fires to the west. Of course, I don't need to belabor that point. It's a tragedy. Beyond that, it's an absolutely gorgeous day to be out here sort of thinking about the value of being able to travel to places like this, the value of being able to work in places like this. It's really stunning. And beyond our USGS efforts here, I think this is a place where we can consider thinking about additional research activities. Certainly Ben Gilbert and his postdoc Sergio have spent some time both collecting samples here and have begun to think about some interesting research questions here. Very interesting opportunities to think about what else could be done here. Some fascinating biogeochemical gradients emanating from this iron-rich spring. Again, the Redwell itself is acidic. It's not thermal, so it's a cold water spring, but very, very iron rich. And you're really looking at, discharge and outflow here, where you're looking at very sharp gradients in algae, filamentous algae, that are both encrusted and unencrusted with iron oxides. There's actually another important source water input that comes from a higher elevation site. That's another spring-fed locality. Again, low pH and also very rich in aluminum. And what you're looking at here is not salt efflorescence, but a form of aluminum oxides. And so as that aluminum-rich, low pH water discharges, as the stream water becomes buffered to pHs above about 3, those aluminum oxides are going to come out of solution. As we move a bit farther downstream, again, the Redwell itself, very rich in iron, you start to induce iron oxide precipitation, and it overprints and screens that nice bright white aluminum oxide. Anyway, fascinating metal story going on here. You're sort of looking up one last thing there at the residue of the Daisy mine. So I'm actually up here starting to think about this interesting juxtaposition between acid rock drainage that has nothing to do with mining per se, and acid mine drainage, of which the Daisy mine there in the distance is a classic example. So really nice juxtaposition between those two processes and how they both govern and regulate flux of metals down to Obi Joyful Creek and the Slate River, which is what you're looking at in the smoky distance. Beautiful day for field work.